It's hard always to predict the future, but there's no doubt, I think, um, the role of computers in human investigation is changing in a very radical way right now. A lot of analyses that we used to do with our own minds and our own hands, and maybe even our own calculators, are now being done more or less autonomously by computers using deep learning algorithms.
Okay, so the next revolution in science and technology, I think we're going to start seeing things even more so that we just never even imagined before. I'm in particular very excited to see where things are coming about from the intersection of different fields. And I think there's really been a huge push for interdisciplinary work. When I worked with the NSF Water Choir, NSF was very big on having interdisciplinary work done. They didn't want a whole bunch of different researchers doing their own thing separately, just as part of a large group. They wanted us working together. And I think if you're part of a team where you're contributing and also learning, then you're doing it right. And I'm particularly excited when I see things that have come out lately with neuroscience and robotics mixed in with, I think, bioengineering and computer science, like helping people who are previously unable to use parts of their body start to move around again. So I'm excited there. But I think just with interdisciplinary work in general, we're going to see some amazing things that we just never expected before.
Okay, I would actually say a good answer to that would be nanoscience and nanotechnology, which is really happening now. And what that is, largely through both really important discoveries in the chemistry of materials, the ability to make materials at the nanoscale level and control their properties, as well as new instrumentation which allows you to look at the properties of materials at very fine length scales.
The next big revolution, I think, is going to be in the sharing of data, the open data movement. We do a lot of work now in sharing genome sequences, and the federal government runs a group called GenBank where they store this information. And I think in every area of the sciences, engineering, the humanities and social sciences, we're going to see an open sharing of data. That means that research can be, there's a way in which we can analyze the data across different subjects. We can get more cumulative effective data by bringing it all together. We can reanalyze, we can detect fraud, we can get I go back to this term cumulative, the more cumulative value of all of the research that we're doing by having open data standards, by having reusable data, by having data that can be worked with in a more extensive way than we do right now.
There's a lot of very exciting things going on with the continuing delving into the secrets of DNA and the way it's controlled, so that the possibilities are endless. CRISPR editing of the gene is just beginning, and we're beginning to understand that it might be possible to change genes in ways we couldn't even imagine before. But it's just this continuing of this revolution of understanding of DNA and the genetic information in the cells that's so astounding in its possibilities.
Well, I think one of the areas that is very important is the medical field. Right? For many years, scientists have done great discoveries to cure diseases such as cancer, now recently Alzheimer's. Before, people died within a short time frame, but with the advancements in technology and science, the science field, in the medical field in particular, mankind has been able to live a little bit longer, even though we're finite, even though we're destined to die. The medical field has done a very good job in that area. So I think this is going to move, it's going to advance, okay? So medicine, since the beginning of time, since the Greeks were the first ones that said that the diseases were not a punishment of the gods, but maybe because of a natural cause. So thousands of years ago, and since then, many good things have happened in this field. But also in the area of communications, You know that technology nowadays is advanced. Back in the 40s, 50s, 60s, we didn't have cell phones, we didn't have computers as we do now. So in a very short period of time, maybe within a 40-year span, we have seen a lot of technological advancements in this area, in communications, right? So I think that is also going to continue.
I play piano. I write music, and I largely do it to get away from my scientific world. But I see in the urge to sort of invent and create when one does music or probably painting or any kind of art, any kind of creative act, something that's very similar to the way scientists, at least some scientists, approach their scientific problems, which is that they have to come up with often novel solutions to difficult problems, and they have to take their inspiration from the world around them. It's not entirely in their heads. And so people who write music are often influenced by the sounds they hear. People who are photographers, of course, are influenced by what they're seeing. Painters, and of course, influenced by what they're seeing. And I think scientists as well have to come up with novel ways of revealing what's in the world, using tools that give them a way to express these things.
I think actually some hobbies, it's good to take you away from your work and your research, just to give you time to decompress, to recharge your batteries. So a few things I do for fun that are a little less connected to science. I like growing plants. You see a couple here in the office. And I really like going on walks, and I love going to concerts. That's something I really enjoy, a wide variety of music. But something that relates to my science directly, that I really enjoy doing, is blog writing for the American Society for Microbiology. I'm a volunteer blog writer for them, for their Microbial Sciences Friday blogs. And about once a month I put out a blog piece for them, and in the interim I edit pieces for my co-bloggers. It's really good because it's a great challenge to improve my own science communication, and it's also a lot of fun, and it makes me stay on top of the literature for microbiology too.
Right, so I enjoy football, but I mean real soccer, then you hear real football, and golf. And they have absolutely no connection to what I do, which is why I like them. Has a tribal following, in not so much in this country yet, but certainly across the world, and I find that very interesting. It's an interesting outlet for tribalism and its supporters. So both the game, which is a beautiful game, and the sociological aspects of it.
Yeah, so I would point to, I don't know if you can see it, my guitar back here over my shoulder or back, and I play in a band, and I am part of the music scene here at Stanford, if you like, at the coffee house and other places. And so, in a sense, it relates, and again, out of this sense of communication and sharing, out of a sense of discovery on my part as I learn new music, and I work with musicians of different generations, so I'm always being introduced to new material, and also the sense of craft and technique.
I enjoy doing a lot of things for fun, mostly reading, going to theater, and going out to eat with friends, being with friends. And does that connect to science? I don't know. I'm not a scientist. I spent my life mostly as a journalist covering science because I find it enormously fascinating. So the connection between science and all kinds of culture is what keeps me going. And it is there should be no limits on it. It's very distressing right now that there is a lot of times when we have this movement in America that's rejecting authority, saying that global warming is a hoax, that you shouldn't get your children vaccinated, this rejection of authority. And that's very disturbing, and I think we need to understand that. But still, it's exciting times in science.
Well, I like sports. I like playing sports, I like baseball. Recently I started playing tennis with my advisor, and we joke around because there's a lot of dynamics involved in tennis. The way you hit the ball, it spins, the momentum, you know. So we have a good conversation when we play, but definitely also baseball, you know, you have trajectory, motion, impact, momentum. It's wonderful. So sports definitely is one of the things that I like and enjoy, but I also can see the physics behind this, right? So really enjoy it.